our last question. We have L, U, B, and A is equal to L times U. We want to solve for Lx is equal to B. Well, that shouldn't be too bad because we have a lower triangular matrix. And we know that L times X, I'll let X have the components chi0, chi1, must be equal to B with components 2, -4. Because it's in lower triangular form, I can use forward substitution. And notice that this is a system that I could find the inverse of if I wanted, but I don't need to. I know that chi0 would have to be equal to 2, and negative chi0 plus chi1 would have to be equal to -4, so chi1 must be -2. So the solution for Lx is equal to B is that x is 2, -2. Now we want to find a specific solution for Ax is equal to B. But recall that Ax was Lu times x, but that's the same as L times U times x, because matrix multiplication is associative, and that's supposed to be equal to B. Well, our solution was that's the case if U times X is equal to 2, -2. That was the solution for L times something is equal to B. It's a little unfortunate we're using the same variable X here because they are two different variables, but I hope you get the idea. Okay, so in fact, this X actually has 4 components: chi0, chi1, chi2, and chi3. Now, we're asked to find a particular solution for Ax is equal to B, which means we need to find a particular solution for Ux is equal to 2, -2. Well, at least if we look carefully at U, it's already in echelon form. So our pivots are here and here. And our free variables are going to be the chi1 and the chi3. So if we want to find a particular solution, we're going to let the free variables take on the value 0 and decide when it's the case that 1, -1, 0, 2 times chi0, chi2, the pivot values, would be equal to 2, -2. Again, because we set the free variables equal to 0 to find the specific solution. Well, we know that that means that 2 chi2 must be equal to -2, which means that chi2 must be -1. But then also chi0 minus chi2 has to be equal to +2. And that would mean that chi0 minus a -1 is equal to +2, and that means that chi0 must be equal to 1. So the particular solution is that x is, or takes on the values 1, 0, -1, 0. Okay, now we have some questions here. Is it true that B is in the column space of A? Yes, we were able to find a specific solution. Is B in the column space of L? Certainly. We were able to find a solution for Lx is equal to B. Now, let's use the knowledge that we've been creating to find two linearly independent solutions of Ax is equal to 0. And again, A is Lu times x would have to be equal to 0, which means that L of u of x would have to be equal to 0. But the only way that L of u of x is equal to 0 is if u times x is equal to 0, because L actually did have an inverse. And so if we were looking at when it's the case that u times x is equal to 0, again, from u being in echelon form, the free variables are chi1 and chi3. So in order to find the two linearly independent solutions, I'm going to now let chi1 be equal to 1 and chi3 be equal to 0 to find one of them. Then I'm going to switch it and let chi1 equal 0 and chi3 be equal to 1 to find another. So again, from u, we know that chi0 minus 2 chi1 minus chi2 plus chi3 would have to be equal to 0 to solve Ax is equal to 0. And that means that, well, let's do the other one first. We also know that 0 times chi0 plus 0 times chi1 plus 2 times chi2 plus chi3 would also have to be equal to 0. So now in this particular case, what we would have is that chi0 minus 2 minus chi2 plus 0 would have to be equal to 0. We also would have that 2 chi2 plus 0 would have to be equal to 0, which means we could solve that chi2 would have to be equal to 0. And that would mean that chi0 would be chi0 minus 2 minus 0 plus 0 is equal to 0, which means chi0 would have to be equal to 2, which means one solution in the null space is 2, 1, 0, 0. Okay, now let's find the second solution in the null space. We would have chi sub 0 minus 0 minus chi sub 2 plus 1 is equal to 0, and also 2 chi sub 2 plus 1 would be equal to 0. So chi sub 2 is equal to -1/2, and chi sub 0 would have to be, let's see, that's chi sub 0 minus a negative chi 1/2 plus 1/2. That means that chi sub 0 would have to be equal to negative 3 halves. So another solution would be negative 3 halves, 0, negative 1 half, 1. Okay, let's put it all together now. If we wanted to give a general solution to ax is equal to b, then that would be the specific solution, which we found on the previous page, 1, 0, negative 1, 0. Plus scalars, we could say alpha sub 0 times one of the vectors in the null space plus alpha 1 times the other vector in the null space, negative 3 halves, 0, negative 1 half, 1. And I think we've finished this sample exam. So good luck studying for the final.